So pardon me a while ago for having a number 6 right here that's supposed to be number 1, and this is the second problem that I am going to solve. So in this case, we are given the integral of sine mx cos nx dx. So in this case, it's actually easier for us if we apply product to sum formula. Because if we actually designate u is equal to mx, then it would take a lot of processes in order for us to get to the final answer. Wherein in this process, it's easier. So sine x cos y, as it is in the form here, is equal to 1/2 sine y plus x minus sine y minus x. So in this case, we have to transform this in terms of this. In this form, I mean. So we have 1/2 integral of sine n plus m times x dx. Because we don't have y and x here, we have n and m. So we just have to multiply n plus m times x, or that would be nx mx dx. The same as here, and it's just different in terms of the sign or the operation, which is subtraction. So in this case, this is the form, the first form we have gotten. So now we have to use the u substitution here. So n plus m x would be considered u, would be designated as u. So this also, in this part right here, we are integrating this separately. And n minus m times x here would be the u. So in this case, if we get the derivative of u here, we have n plus m dx, and in order for us to get the dx, we just divide n plus m to both sides and we get 1 over n plus m du. In this case, 1 over n minus m du, because the only difference they have is that this is minus. And it's not addition as same as a while ago. So now we have these values right here, and we now substitute them to the original equation, and this is now in terms of u. So 1/2 outside the integral sign, and the integral sign of sine u over the value of dx is 1 over n plus m du. Same as here, you just substitute what you got from here. Now we will arrive at this function right here. So the integral of sine u du, that's common to both, that would be negative cos u. In this case, I just put the negative sign right here because it doesn't have a negative sign in its constant, so that would be like it would eventually go to the constant later on because they will be multiplied. In this case, this is already negative, so I put the negative sign near cos u in order for me to distinguish the negative signs. And when you multiply them, they would become positive. And this would become negative, of course. So after this, we get this negative 1 over, yeah, you can just read it like that. And in order for us to like fully simplify this, we can put this in the numerator part, and same as this one right here, or we can just flip this up, and this would become the first term, and this would become the second term. Either way, it's the same answer, and this would be the final answer for this problem.